Hello, and welcome to our first lesson for our statistics unit, or not the first lesson, but the first video lesson. So today we're going to be talking about displaying data, and I thought it would be better to see it visually in a video instead of read it and do it yourself for this time. So in the top right here, it talks about types of data, and I linked you the blank lesson if you want it and you want to write down along the way, but you don't have to, you can just listen. So there's three types of data that you can collect. So categorical data has to do with data that's like a type of something rather than numbers. It's usually qualitative data. So an example of that is you're checking out checking an age range on a survey, which I guess age range is a number, but if it's a range of values, then it's different. Collecting a survey about favorite colors, favorite TV shows, anything that's of some kind of a category. Sometimes categorical data is recorded as a number, but the value of the number is not as important as what it represents. Just like checking the age range, we're looking more at the range of numbers rather than individual. Seen in those surveys that you ask for a rank from 0 to 10 based on the degree to which you agree. So 0 meaning disagree and 10 meaning agree. The number isn't, it's important, but it's really more what is the meaning of that number. So it's a category. For continuous data, this is numerical data. So now you want numbers where values exist within recorded values. So decimals are allowed. That's a big difference between this one and the next topic. Decimals are allowed. This is quantitative data. Quantitative means you're measuring a quantity, a number, a value. You're recording it. So for example, the heights of students in our class, that would be continuous because you can have any decimal in between. It's not just you are 130 centimeters or 135 and that's it. Like you can go anywhere in between decimals. And finally, discrete data, data that is distinct and can be counted, also numerical. So really that means there's no decimals here. So I'm going to even write that there. No decimals. So for example, money in cents, we don't take 2.5 cents, not possible. Hockey scores, another big one there is shoe size. I guess you can go into halves, but that's it. There's no 3.25 shoe size. It's not any decimal possible. So in our first example, you can pause it if you don't want to see the answers. You want to try it first. Otherwise, I'm just going to talk through it. So the number of emails received in a day, well, we definitely want a number here, but then we have to ask ourselves decimal or no decimal. You can't get a half of an email sent to you, so we are going to go with discrete data here. The type of pet that you have at home is not a numerical value. It's actually something that can be put into categories. So we're going to go with categorical. And the amount of coffee in milliliters drank in a day, you can have a half a milliliter or a quarter of a milliliter or 3.11 milliliters. That's a very small amount, but the point is that you can have decimals. So we're going to go with continuous. So if you are checking your answers, I hope that you got those. So after we do all the data collecting and we have our type of data, then we have to decide what type of graph do we want to use to show it. So the first one you may have heard of and maybe not seen it in a while is a histogram. This is a type of bar graph, and the bars are used to represent continuous data. And remember how we said that continuous data has no decimals? So our bar graphs actually touch because there's no breaks in the data. Each bar represents some kind of an interval. So usually we're looking for some kind of a range, which you can see here like 0 to 10, 11 to 21. There's some sort of range. A bar graph, which you've seen before and very familiar from our last unit. It's similar to a histogram. There are bar graphs, but actually the bars don't touch. That's showing us that there is actually space between our data. So we're going to use discrete data in bar graphs, and histograms here, continuous data, so we put that there. And finally, a pie graph. You've probably seen pie graphs all over the news. You see pie graphs all the time. It's a circular graph divided into sections proportional to the data. It's a very nice visual graph. It shows you like what's the most popular right away. And we use this for categories as the easiest way to represent. Those are your 3 types of graphs, and we're going to take a look at how to make those as we go forward. So the first one is already done for you. Here, I'm not going to take the time for you to watch me make a bar graph because we already did a video on bar graphs. Just some things I want to maybe point out, that you need a title, you need to label your 2 axes. Notice how there's spaces in between these bars. We have a scale over here, and you have labels for everything on your x-axis. So all the categories are labeled. Could we have also used this categorical data and put it into a pie graph? Absolutely. So our next example is another example of categorical data, and you can see here it's talking about a budget. So you have a monthly budget, these are your categories, and we can turn it into a pie graph. So we're going to go through the steps of how do we do that by hand, but then tomorrow you'll see in the video that's posted that I'm actually going to show you how to do this way faster by using the computer, right? It makes more sense to use our resources, use our Chromebooks to you get the computer to do the work for you. So if you know how to do that already, awesome. And if you don't, then I'm going to show you, because you never know when you're going to need that skill working with data in the future. So you can see over on the right there, there's that little kind of instructions to tell you how to calculate this. So you want to find the amount of each item divided by the total amount or total worth here, and then multiply it by 360 degrees, because that's the total degrees in a circle. So you can see here, if you add up the total, we get $2,100. So our first example, we'll say taking 900 divided by our total of 2,100 and multiplying that whole thing by 360. And when we do that, we get 154. Going to do the same thing again with transportation. So now it gets pretty repetitive. Multiply it by 360 and you get 69 degrees. You're going to do the same thing again with food, with clothing, with entertainment. And you get 86 degrees, 17 degrees, 34 degrees. And if you test it out and you add it all up, you should get a total of 360 degrees. And you can double check for me, but it does add up to 360, which is perfect, because with rounding you could get close to like 359 or 361, which is also fine. And then technically you would have to, find the center of your circle, use a protractor, split it up. Let's say for the first one we did rent, you have to continue and keep on splitting it up, and this is transportation and this is food and etc. But you don't have to, because you're going to see how to do this tomorrow. And I will probably use this exact example so you can see what it would look like. We know what the biggest space is going to be. First it's rent, then food, then transportation, entertainment, and then clothing. But to visually see it is definitely different, but we'll see how to do it using a computer tomorrow. So our last graph is a histogram. So we're going to take a look here at how do we take the data, put it into our frequency table, which is something that you've seen before, and then make a histogram. So the first thing we want to do is take all that collection of data at the top there and actually turn it into our frequency table so we can actually make sense of it. So we already have the ranges already set out for us here. And notice on that yellow star on the side says to make sure your intervals don't overlap. If they do, then you're going to end up counting twice, and we don't want that. So I like to go through the data one by one, put my tally in the correct interval, and then cross it off. So first one's 21. Here's my tally for 21, cross it off. My tally for 35, cross it off. And you keep going, so I'm going to skip through this. But you keep going until I pre-filled this out so that I could go through it quickly. So that's why I'm not actually going this quickly. It took me longer when I did it the first time. Okay, so now we have all of them. And once you have all of your data, see how I've crossed off everything off. I just want to double check. We want to see, well, how many pieces of data do I have? And even though the question says 30 people, there's actually only 28 pieces of data. So we're going to cross that out and put 28. If you count up all your tallies and put them in the frequency chart, so the first one has 5, then 6, then 9, then 5, then 3. If you add all those up, then you get 28 in both, which is perfect, exactly what you want. So what's the most common number of trips made to the movies in a year amongst the people who were serving? And if you look at our data, then we would say the range between 20 to 29 trips per year is the most common because it has the highest by 9. So now that we have all that data, we want to take that and turn it into our histogram. Histogram is very similar to a bar graph, remember, but the bars touch. This type of data actually probably could have been used in a bar graph because it's not continuous data. It's actually discrete, can't really go to the theater half the time. But really we're just looking here to see how do you make a histogram, what does it look like. So let's focus on that part of this. So we want a title, so let's call it Trips to the Movies, or Trips to the Movie Theater. You also need, oh no. All right, well, I guess we'll take it from here. So, Trip to the Movie Theater. You have a title. You need to have your other titles here. So this would be number of trips. And this would be our frequency. I tried to write sideways, but that didn't work. So we'll go from there. We also need to have our frequency on the side here. We need a scale. So that would be going up by ones is perfect. 9, 10. Our high says 9, so that's perfect. It all fits. And here's where it gets trickier. It's different in the histogram because they're actually all ranges. So I'm going to say, I don't know, 2 spaces per range and call this 0 to 9. We'll go with 10 to 19 for our second one. We'll go with 20 to 29. And you just keep following because you were already given the ranges anyways. And our last one is 40 to 49. So we kind of have it set out there that every 2 blocks. Could I have made it more? Probably. Doesn't really matter. You can make them all 1 block wide. It doesn't matter. And now the fun part is putting in our data. So let's see. Our first one has 5. So we can draw our bar graph up to 5. Color it in. Our next one has 6. So notice how the bar graphs are now touching. 20 to 29 has 9. We'll make our bar graph go up to 9. 30 to 39 has 5. And our last one has 3. And now you could probably color it in nicer without a stylus here. Now you have a histogram, and now you've seen an example of all the different types of graphs. So hopefully that makes sense to you, and it will be nice and easy to make that transition to not making these graphs by hand tomorrow. Have a great rest of your day.